Hi students, I wanted to give you a brief tutorial of how to use the Desmos graphing calculator, and I'm going to graph a geometric and then an arithmetic sequence that is a discrete sequence. So first you want to go to the website desmos.com/calculator. If you do a Google search for Desmos, this is probably the site that comes up, but Desmos does have some other types of calculators. And we have an untitled graph. You can see our graph over here. If you want to adjust the axes of the graph, you could click this wrench tool in the right-hand corner, and you could get rid of the minor grid lines. If you want to just make it easier to read, you could also make your X and Y axes increase by 1 instead of 2. So you can kind of play around with some of these settings over here. You could see that the x-axis goes from -10 to 10, but another way you could change that is using the zoom in and zoom out features on the screen. Or if you are doing this on your school computer, you can actually pinch and use your fingers to zoom in and zoom out. So I know you can't see what I'm doing, but I'm just kind of pinching the screen together and moving it out. If you ever get really far away from the view you want, you could just hit that home button and it'll take you back to kind of the default that you had just set using the wrench button. Okay, so let's say that I want to graph a geometric sequence that is a discrete sequence, or I could think of this as a discrete exponential function. The way we can graph this discretely, sorry, not really, that was a play on words, is we can enter the recursive function. So let's say that our sequence has a common ratio of 2, or I could think of that as a growth factor of 2. And so right now I've made the recursive rule f of n is 2 times f of n minus 1. So twice my previous term. And you can see Desmos then prompts me to add a base case, and it defaults to f of 1. So if you recall, in a recursive function, you must always give the reader a number to start with. So we could start with 1. You can also change this. Maybe I want f of 0 to be 1. Or actually, maybe I want f of 0 to be the number 2. Okay, so I have set up my recursive function. It's these two statements together. And you'll notice that now this little icon appeared next to the recursive function, and it's going to let me create a table. So if I click on that icon, now Desmos has used the recursive rule that I made to create this table of values. Now you might notice that only the first 4 points exist here. So I could see, if I kind of stretch my graph, that, let's see, I wonder if I can change this from blue so that it shows up as a different color. I think there's a way. I don't remember how to do that though, so I'm not going to worry about it right now. But I could see that the point 432 is on my graph, but or I could also zoom out to see that. So there's the points on my graph. But those are the only points that Desmos just graphed. And maybe I want this function to take on more values. So the easy way to do that is just click in your table and just use the down, whoops, maybe not the down arrow, use enter, sorry. So when you click in your table and you hit the enter key, it's gonna just keep repeating that recursive pattern in your table. And if you've ever played the phone game 2048, you might recognize some of these numbers. So you can see I made numbers so large that now Desmos is using scientific notation. So as I look, I have now created the recursive, it is a recursive geometric rule that we wrote for a geometric sequence, and I could think of this as being an exponential function that is discrete, and the domain of this function is all whole numbers, because I had my function start at 0 when I gave this base case, and the recursive rule only works as n increases by 1 whole. If I instead changed my base case to the number 1, for example, now 0 is not part of my domain. So the recursive rule will not go backwards and find f of 0. And so now my domain of this particular function is all counting numbers, or all natural numbers. All right, lastly, let's say that I wanted to Let's say that I wanted to keep this graph, but I actually wanted to look at an arithmetic sequence instead. What you can do, instead of deleting this, you could just turn the table off. So when I click this blue icon here, it just turns off the table. So my data is still there if I want to turn it back on, but I could just choose not to look at the graph. And I could scroll down and find a spot to make another equation. So let's say that I made the arithmetic rule that I have a decreasing arithmetic sequence. Each term decreases by 7, and our first term is, oops, my play button is right in the way here. I don't know why it's letting me not do this. You know what? I think just because I'm going to go back up to the top. I am actually going to delete my verse sequence. So if I make my recursive rule for an arithmetic sequence, here we go. I'm going to add this base case. I'm going to say f of 1 is 10, and I'm going to say my sequence decreases by 7. So again, once I type in my rule, I hit this button to make a table. Now I can see that table has started. If I want more points on my graph than just the number of points in my table, I can go to that last row and I can hit the enter button. And as you can see, Desmos will keep graphing for me.